Hello and welcome to our SOL review of 8.3 radicals. So one thing I really need to focus in with radicals is factor. You're factoring. So you want to think of all the multiples of these numbers. And what we're going to do is we're actually going to use factor trees to help us kind of break up how these square and cube roots work. So if we're going to start with our number 45, and you want to think about what multiplies into 45. You might say 3, 9, but you're probably going to pick the more obvious answer, which is 5. And what number would I multiply with 5 to get to 45? Well, that would be 9. And what you're looking for are prime numbers. And you'll see why we're doing this in a second, but 5 is a prime, so that's good. Our tree kind of stops there. There's no more branching out. However, 9 is not prime. We can break it down into another set of factors, 3 and 3. You keep going till you're out of branches, basically, that you can make, and you've got nothing but prime numbers. And what I'm going to do is clean this up to 3 times 3 times 5. And in our little math world here, we like to say a little phrase, couples go out, singles stay home. See, if you're a couple on a Friday night, you want to go out. You want to be seen on the town. You want people to know, hey, we're together. We're an item. We're 1-3. And you're out of the party. Meanwhile, the lonely 5 is forced to stay home and, well, they're going to just play video games and eat popcorn and be lonely. Now, that actually sounds like a good life sometimes, but you always want to be out and social and seen, so couples are going to go out like that. Now, why exactly does that work? Well, this is the cleaned up answer. Now, here's the real reason. 3 times 3 is 9. And we can actually break this apart to be the square root of 9 times the square root of 5. Little side note, this does not work for addition or subtraction. The only reason you can break this apart is because it's multiplication. So I would like to reiterate that. This does not work. You cannot break apart addition and subtraction like that. But we all know the square root of 9 is 3. And the square root of 5 is some really ugly decimal, so we end up with that. So you can actually look at it like two ways. You can look to see which couples are going to go out, or you could just think, hey, what's a common square root I could take out of this, like 4, 9, 16, or 25? We can even do it with variables. I'll get there in a second. Let's go ahead and factor 40. I'm going to take the easy way on this and do 4 and 10. It doesn't actually matter what number you started with. I could have done 2 and 20, or I could have even done 5 and 8. But you're going to end up with the same factor tree at the end, I promise. You just got to make sure that the two numbers multiply to the original. 4 is not prime, so we're going to keep going. We're going to get 2 and 2. Cool. 10 is also not prime, but we can break it down to 2 and 5. Those are prime. Now, I've talked about x cubed and how we can actually write this as x times x times x, and you'll see why I want to do that in a second. So, pull up a big square root. We had 3 2s, so 1, 2, 3. We had 1 5, so he'll stay home, and then we had 3 x's. And I'm going to use the same phrase from before. Couples go out, and singles stay home. We had a single 2, a single 5, and a single x. So we're going to go ahead and put a 2 on the outside and an x on the outside. And again, you might be thinking, well, why didn't I bring both 2's? Well, remember, what's the square root of 9 over here? It was 3. That's why we ended up with a 3 on the outside. 2 times 2 is 4, and the square root of 4 is 2. Now on the inside, we're left with 2 times 5 times x. Well, numbers we can clean up, so the real answer is going to be 10x. Now, what if it's a cube root? Well, alright, instead of a couple goes out, cube means 3, so trio. You need a trio. You need 3 to go out. So what we're going to do is the same thing we've been doing. We're going to factor 24. So 4 and 6, neither of those are prime, so 2 and 2, both those numbers are prime. Let's keep going with the 6. There's a 2 and a 3. And like I was just saying, you need a trio to go out. Even if I have a couple, it's not going to work. It needs to be a group of 3. And, well, we have a group of 3. There's 3 2's. And a 3 is going to stay inside. And that works because 2 times 2 times 2 is 8. And the cube root of 8 is 2. Don't believe me? Type it in a calculator. Let's go ahead and take a look at an SOL problem. So, what is the value of the square root of 128 in simplest radical form? Now, I know one thing my students love to do is they always say, well, it's even, so let's divide it by 2. And that's not wrong. I mean, that works. But I'm going to pick a little bit more exciting of a factor here. I'm going to go ahead and pick 8 and 16. So what we're going to do is we're going to factor 8, because neither of those are prime. We're going to keep going. Oh, there's a 2, but there's a 4. And again, it's always good to do really quick just to check, like, hey, 2 times 4, it's 8. Cool, I'm on the right path. Let's factor 2 again, so 2 and 2. We're done with this branch, but we still got this 16 to go. I could do 2 and 8, or I could do 4 and 4. Doesn't really matter. It's going to work out to the same tree. 2, 2, and another 2, 2. This has a lot of 2s. Wow. So many 2s. Ooh. Well, makes sense considering it's 2 to the, I believe, 8th, if memory serves. So here we go. 1, 2, 3, 4, 5, 6, 7. Ah, it's 2 to the 7th because there's 1, 2, 3, 4, 5, 6, 7. There we go. Shoo. I'm going to write 2 7 times. 1, 2, 3, 4, 5, 6, 7. Double check. 1, 2, 3, 4, 5, 6. Yeah, I did it right. It's a square root. Couples go out. If it was a cube root, a little 3 up there, then it would be triples or trios go out. But since it's just a square root, couples go out. So we're going to have 1 couple of 2s, 2 couples of 2s, 3 couple of 2s, and 1 guy by himself, unfortunately. So I need 1 2 on the outside for this couple. I need a second 2 for this couple, and I need a third couple on the outside. Wow, party is 6 going out. But unfortunately, 1 guy's staying home by himself. 2 times 2 times 2, well, that cleans up to be 8. And the square root of 2 stays behind, which gives us the answer of A. Thanks for watching.